Welcome. The title of today's notes worksheet is Double Angle Formulas. And so today, as the name suggests, we're going to take an input and we're going to multiply it by 2 and then kind of work with the ratios of that new angle. So if you remember, so far we've combined angles with addition and subtraction, and today this is what's called the doubling formulas. And so the proofs are relatively straightforward and simplistic, so I figured I'd kind of walk you through as to how they come about. Plus it uses some things we've talked about before. So worthwhile here of our time, and then we'll just do a few problems together. So let's start it out here. It says investigation, proof of double angle formulas for sine and cosine. And so here's what I'm thinking, just in the initial blank. Remember what doubling actually means. Doubling means multiplying it by 2. And when we multiply things by 2, it just means repeated addition twice over. So when I say 2x, really what that means is x plus x. And so that's exactly how I'm going to play out that 2x right there. And then as you can see, all of a sudden, this is just the sum formula for sine. Now what makes this one unique, of course, is that the two angles that you're combining together via addition are the same, x and x. But I'm still going to go ahead and use it. And so basically the idea would be I take sine of the first, there's the first, cosine of the second, there's the second, and then plus cosine of the first and sine of the second. And again, it just so happens that the two original inputs here are the same, both x's. And so as a result, I have sine x, cosine x. And here, everybody, I hope you agree that's the same, sine x, cosine x. And when I'm adding the two together, it just means I have two of them. And so as a result, there is your first formula for the day. Okay, not bad at all. Probably one of the easier ones to use. So when we double the angle measure and talk about its sine ratio, that ratio is all based on the sine and cosine of the original angle. So we will need these two components in order to get this over here. Okay, good. Now here's what's interesting about cosine. Do you see right here, everybody? There are 3 different variations. I'm afraid you're going to have to know them all, but well, let's develop one first and then kind of see where it leads. I would say we probably use one more than the other 2, but all 3 are fair game here. So let's see. First and foremost, cosine of 2x. Same premise, guys. 2x is really just saying x plus x. So now, as you can see, when I talk about the double angle formula for cosine, it's just here, the sum formula for cosine, just the same 2 inputs. And if you remember this one, it's cosine, cosine. So cosine first, cosine second, minus sine of the first, sine of the second. And so if I asked you to simplify that piece, you would come up probably with cosine squared of x minus sine squared of x. Good one right there. Now here's the beautiful thing, and interesting, there's just so many good connections here. Just one slight modification. Hey everyone, if this was a plus instead of a minus, what is cosine squared of x plus sine squared of x? Well, as we all know, and from the beginnings of this unit, cosine squared plus sine squared is 1. But cosine squared minus sine squared relates to an entirely different angle measure and its cosine ratio. So totally different. Change the inputs and it's the cosine ratio. All right, so that's the first. Now we're going to use the concept of what I just developed here to get the other 2, because we can do a little substitution in this. So I'm just going to work off to the side, and I'll try to put it in parentheses to kind of separate it out here. But as we do kind of remember, of course, that cosine squared is equal to 1 minus sine squared. So try to picture this for just a second. What would happen if I took 1 minus sine squared and I substituted that in place of here, using it kind of as the identity ideal? So this is 1 minus sine squared. And so you would have 1 minus sine squared minus sine squared. Or that's what you would have. So the cosine of 2x can be written all in terms of the original sine ratio. So just by substituting 1 minus sine squared in here. Okay. Now, if I did that to get the second one, you can maybe see what I'm going to do for the third. And I'm going to replace that sine squared from the original to this. And of course, here's the idea. This is the same as sine squared. So what would happen if I took the original formula that I developed and put 1 minus cosine squared in here? Now this one's a little harder to see, so I will just work off to the side for a sec. But I had this. There's your cosine squared. And then minus, and always be careful with subtraction. And so what would that look like if I made you remove the parentheses, distribute the minus sign in to here and to here? What would you end up getting? And if you did it properly here, you would see actually that you get 2 cosine squareds, because the minus the negative changed that to a plus. So 2 cosine squared minus 1. Alrighty, so I'm going to box up all 3. Sorry for being the bearer of bad news, but yes, you do have to learn, know, memorize, whatever word you want to call it, all 3 variations of the double angle formula for cosine. So all 3 variations, please. Sine, probably the easiest of the bunch. Cosines, yeah, a little harder, and obviously different variations, but we can still get it to work. Okay, good. Let's move forward. Ooh, great one right here. I forgot about this one. So example 1, verify the identity. Now I know I never talked about a triple angle, and that would be this case right here, but you'll see it'll overlap nicely to what we do. And I'm going to some degree, contradict all of what I've said before with verifying identities. Usually what we want to do is go from the more complicated side to the more simple side. In this case, I'm going to reverse it. And as a matter of fact, I'm going to make this look like this over here. So all in sine, what's kind of fascinating about this particular equation is that it is all in sine. This is a triple input. Here's the original input, but the output is cubed. So it's like 4 times sine of x, and that sine of x is all raised to the 3rd power. So I've got different inputs. I've got different powers of the output, but it's all in terms of sine. Okay, I'm going to get the ball rolling. I would love for you to just keep pausing and seeing if you can go a step ahead of me and then come on back. I mean, I have to leave this obviously to your discretion, but I would encourage you to do that. So as I said, certainly getting the first step going here, and here's where the 3x comes out. It is really just 2x plus x. So a triple angle obviously is just a double plus a single. And so now we've got some really interesting things going on because I have 2 different inputs, the double x and then the x, and it's the combination of the 2 via addition that gave me this piece right here. So by treating 3x as 2x plus x, I now have the sum formula for sine. So I'd ask you, pause the video, expand it out, see if you're really remembering your stuff. I've developed these notes worksheets so you would have a lot of overlap there and be able to kind of utilize some of the formulas from 2 days past or 3 days past and so forth, so you don't forget them. Anyway, here's how it works. Sine of the first, cosine of the second, plus cosine of the first, and sine of the second. Okay, that's it. There's not much I could do there. Now, I'm hoping everybody does realize that the other side of the equation is all in terms of the original angle, just in terms of x. So something tells me this, it's got to change. And this also has to change. And we have a way to do that now. If you look at the formulas up above, we can change a double angle into its single angle. This one speaks for itself. There's only one way to pull it off. So when I see sine of 2x, without even blinking, I know it's 2 sine of x cosine of x, and then times another cosine of x. Okay, good. Now here is the moment of truth, basically. The good news is we can't really go wrong. We have three choices, and the bottom line here is any of the three would work. I would argue one is certainly better than the other two for this particular problem. And this is just the idea of forming good strategy. Look at the other side of the equation. Look what it's all in. Look at our three choices and what would make the most sense as a result. So what I'm seeing, guys, is this whole side is in sine. And so if I have the choice amongst these three formulas to change cosine of 2x, I think it benefits us to use the one that only has sine in it. Why introduce cosine if we don't have to? So what I'm thinking is this is going to be the one that we're going to use, the 1 minus 2 sine squared of x. And so that's what I'm going to do, everyone. It is a quantity, so 1 minus 2 sine squared of x times sine of x. Okay. And by the way, I did have to start raising these to a power here, so that's good. All right. Now again, it's all in terms of sine. So think how we're going to do this. You could start parlaying a few steps into one. I'm just going to try to be as clear as I can up here with what I see. I'm just going to go with one thing first. I see that cosine times cosine is cosine squared. That's good, so I'm just going to change that for right now. And think about it. Think about your goal. Everything has to be in terms of sine. So the question is, can we put everything in terms of sine? I'm almost there. Here's all sine. Here's all sine. The only thing that's not quite compatible is this piece right here. And everybody, do I know how to change a cosine squared into the sine ratio? Oh, absolutely. And how do we do that, of course? Well, I know that cosine squared is 1 minus sine squared. We have seen this so many times, but that is a great change for this problem because, again, everything has to be in terms of sine. I need to get 4 sine cubes, however that's going to work out. So I need to get more powers and sine in there, and this is it. That's a great opportunity to do that. So let's see. Okay. Now I think it's just a matter of cleaning this out a little bit. I think it's time to remove parentheses and see what we have, how many terms and what they are. So I'm going to distribute, everybody. You distribute as well. And I have 2 sine of x. And then here it is. Notice sine times sine squared is sine cubed. So I'm almost there. Then I do the same thing over here, everyone. Distribute. Let's remove those parentheses. And I get a sine of x and take away another 2 sine cubes. And I think we've got it. All in terms of sine. 3 sine x's taken away 4 sine cubes. Excellent. And I'm going to bring it down. What the heck? 3 sine minus 4 sine cubed. And there it is. We've proved it. Look that over, of course. Obviously, kind of going through it the first time is certainly by no means easy. But if you keep strategies in the back of your mind and you know which formulas you're going to apply, it's just a matter of letting it loose. Okay. There happens to be a formula for the double angle on tangent. So it would be the same thing as what I did above. If I did the sum formula for tangent and kind of worked with that, you end up getting this piece right here. I will not make you memorize that. For all the problems that we're going to use, again, if you need it for some particular reason, you at least have it in your notes. But the bottom line here is tangent of 2x, we're going to treat as just sine over cosine. Okay, just like we did before. Well, let's try one big example all the way through, and then if we need some reinforcement, we'll do that third example that I see on your paper as well. So let's give it a try, everyone. Again, we're talking about really the primary ratios, sine, cosine, and tangent. Here they are, sine, cosine, and tangent of a new angle based on the original. So in this case, the new angle is created by doubling the original angle, doubling the original angle. So all the trig information on the double comes from the trig information on the single. And as it says, actually I would box this up. Please guys, use a drawing. I just can't stress that enough. This is such a visual course to begin with. So I guess the way I'm going to do this is very similar to the way I did this on the last notes worksheet. In this case, it's called theta. I guess that's our input. I'm just going to put a theta there, and then I'm going to put a 2 theta here, just labeling it that way. That's sort of poor form on my part, but that's all right. I think it still works. So let's go for it. Let's talk about the original angle and then get the preliminary information on it, and then use that to talk about the double angle. So here's what I have. Tangent of theta is -3/4. Sounds good. And looks like we're going clockwise here, everyone. So it's in between -pi/2 and 0. So I see that a negative tangent ratio, and then this is the interval. I'm definitely seeing that somewhere down here, give or take. And this would be theta. And the y/x, well, the y going down, and be very careful with your labels. Can't stress that enough. If you label it wrong, you're going to likely make one minor mistake, and then the rest of the problem goes up in flames there. So just be careful. So y to x, everybody. -y, +x. Excellent. And I would argue that r is positive. So there we go. 3, 4, 5. Nice. And same deal. I think we did this on the last notes worksheet. A and B, guys. Tie them together, and this would be the preliminary steps. If we're going to talk about anything on the new angle, everything has to come from the original. So nice and easy here, people. Sine of theta, y/r. I look at my diagram. The y is -3, the r is 5. So -3/5 is the sine ratio. Cosine, again, keeping it nice and simple there, everybody. X to r. X is 4, and r is 5. And so the cosine ratio for this angle is 4/5. Perfect. Now we're going to double this, so if you can envision this, I went from here to here on the original. Now basically I'm going to double that, so I'm going to go further clockwise. You know, where would that lead us? Where am I going to draw it? I don't know. We're going to need some more specifics here. So let's go for it. And it just says now find sine of 2 theta, cosine 2 theta, tangent 2 theta, etc., etc. I am probably going to have to work horizontally on this. Sorry about that. I like it better vertically, but hey, it is what it is with my board here, so we'll see what I can do. Anyway, sine of 2 theta is 2 sine theta cosine theta, which, of course, we just did the preliminary steps there. We have those two pieces. We have the sine ratio for this input, for this angle measure. We have the cosine ratio as well. I like doing this for this particular type of problem, everybody. Remember, 2 is just 2/1. So I do that because these other two numbers, of course, are ratios. That's what the output is. It's a ratio, and so it's going to be a fraction. So I guess I have 2 times -3/5 times 4/5. Put them all in parentheses. I don't know. However you want. Whatever works for you, of course. And then keep it nice and simple. We are going to, of course, multiply straight across there. If you can cross cancel, I would certainly do that because you're not going to add anything here. But ultimately, 2 times -3 times 4 is -24. And 1 times 5 times 5 is 25. And there, everybody, is your sine ratio for the double. Excellent. So sine of 2 theta is -24/25. Now here's the thing with the next one, part D. Cosine of 2 theta, you have 3 choices. And it's up to you which one you want to do. Just over the years, students have sort of let me know that the first one is probably the best one in this case. So I'm going to go ahead and do that one. So it's cosine squared of theta minus sine squared of theta. As I mentioned, really any one of the 3 would work. I've seen students over the years have some issues with having only one ratio and then the 1 somewhere like a 2 cosine squared minus 1. I don't know. I like this one. And again, I think students over the years have said this one works best. So let's try it. It's basically, remember what cosine squared of theta means. Be very careful on that. It's not theta squared. It's the ratio squared. It's cosine of theta squared. So we all know, based on what we found, is that cosine of theta is 4/5. So that's the ratio, and that's what we're going to square. So it's 4/5 squared. And then minus, and then we're going to do the same thing here, everybody. Negative 3/5 is the sine ratio of theta, and we are going to square that as well. So cosine squared minus sine squared. I'm hoping everybody is okay with that piece. I'm going to just keep going horizontally here. Squaring, we've seen this as an exponential property before. Remove the parentheses, and we get 16 over 25 minus. Even when we square this, everybody, I'm hoping you see that negative 3 squared is just 9. And so we get that piece right there. Okay, looks good. Now 16 minus 9 works out nicely to 7, and 7/25 would do. Okay, take a look. See if that works for you. Ratio squared minus ratio squared. And because they did have the same denominator, it's always obviously kind of nice. We got that piece right there. Okay. 2 down there, 1 to take care of in this case. I think of it as these from this perspective. Rather than having to apply the whole new formula, we already solved for these two pieces, so we might as well use them. And as said, I think I showed you a shortcut before on the last one, but basically, let's see, we did the sine ratio, that's that. We just did the cosine ratio, that's that. And we already talked about this, the 25s are going to cancel. And remember, this is y to r, this is x to r, and tangent really is y to x. So it's negative 24/7. Perfect. So we have our ratios now really working out nicely for us. So that would be doubling the angle, and those would be the trig components that go with it. The primaries, of course, sine, cosine, and tangent. Now everyone take a look at letter F. It does say this. This is intriguing. It says what quadrant is theta in. So let's talk about theta. Oh, we already did theta. Oh, theta was in 4. Sorry, we already drew that. And it says what is theta. Okay. So here's what I'll ask you to do. If you can bring up the calculator here. And again, you're not responsible on these problems. This is really above and beyond because we don't really have the foundation to do this comfortably. But I'm going to go ahead and just make sure, first of all, I'm in degree mode, which I am. And I'm just going to do an inverse sine on my original sine ratio there, which I think I saw was negative 3/5. So guys, I'm going to do inverse sine of negative 3/5 up here. And I get that. And that does fit the way I drew theta, everybody, kind of rotating clockwise into the 4th quadrant. So I'm going to write this, everyone, as negative 36.87. Okay, good. And it does say what quadrant is 2 theta in. Well, we can do this 2 different ways, I suppose. We'll verify it in just a sec. But I would encourage you to think of it from this perspective. Look at our ratios for 2 theta. Sine is negative. Cosine is positive. And tangent is negative. What is the only quadrant where that occurs? Sine negative, cosine positive, tangent negative. And as you can see, it would be in quadrant 4. So theta is, or double theta, is definitely in quadrant 4. And you can see that right here, everybody. If I took this number, which is my original theta, and if I multiplied it by 2, it would give me in the 73-degree range, give or take in there, negative, rotating clockwise. So that would be staying in quadrant 4. And so what that would look like, and by the way, we should go on back. I wanted to be visual with this. So this is basically taking this and doubling it. It just brings us further down, sort of looking like that. And now take a look at the ratios there. This would be a positive 7. This would be a negative 24. And this would be a 25. Do those numbers kind of match the scenario with this rotating further and closer to the y-axis? There, everybody, is my 2 theta from there to there. Sorry, that doesn't look great, but that would be 2 theta. Perfect. Okay, let's see if I've solidified everything. Oh, 2 theta. So if I actually did take, let's do that together. Let me bring the calculator up one more time here. And how about just times 2? So about negative 73.74. Perfect. Now, we should just see, is there consistency there? What if we took the sine of this number right here? Should it be this? What if we took the cosine of this number here? Should it be this? Let's see. Again, I like that connection. It's a little above and beyond what we're doing here, but I really like seeing it and making sure that there is consistency here and that you're seeing the connections. So let's do this together. I'm going to do sine negative 73.74. Again, I'm rounding here to some degree, although I should have just done the answer, but oh well. And I get about negative 0.96, really close there. What happens? That should be the sine ratio of this angle. And by the way, what of course is negative 24 divided by 25. When we found the sine ratio of our double angle, notice, there it is. Same with cosine. Let's do cosine of our double. So again, I shouldn't have rounded. I should have used the answer there, but that's all right. Too late now. So about 0.28. And let's see, where did I find it? Oh, cosine right there. That's interesting. Sorry, couldn't find that for a sec. But I think our cosine ratio was 7 over 25. And there it is, 0.28. And you can see, obviously, that matches nicely. So our diagram works out nicely. When we found the angles, our answers make perfect sense. There's perfect continuity with that. All right. Good. We'd love to see you try just one pretty much on your own here. We'll shortcut this a little bit. I won't go through the whole inverses and finding the angles and so forth, but you should be able to kind of pull off something like this. So I'll do one more with you. If you know what you're doing at this stage, I mean, either you can go ahead a little bit or you can sort of pause the video at this point or end the video. I'll leave it to you, of course. But I'm going to do one more. I've got the motivation to pull it off, so why not? So it says sine of theta is 5/13 and theta is in quadrant 2, which would look something like this, give or take. Y to R. Must be able to label your diagrams correctly. So 5 to 13 is the Y to R. If I did a little Pythagorean theorem, everyone, should be negative 12. So going to the left, X is definitely negative. And so as a result, just based on that diagram, here's cosine of theta. Here's my theta, everybody. There's your X to R, which is negative 12/13. So that's the preliminary step. Now everything is just based off of that. Let's go ahead and do a sine and cosine and tangent on the double from the trig ratios on the original. So what I do for this one, everyone, is just 2 over 1, and in the sine ratio of theta, which is 5/13, and in the cosine ratio of theta, which is negative 12/13. So it's just like the last problem there. So if I'm shortcutting you a touch, I'm sorry, but this is 2 sine theta, cosine theta. And then very simply, I'm just going to multiply across. 2 times 5 is 10 times negative 12. I get negative 120 over 169. That would be the sine ratio of doubling this angle right here. Okay, box it up. Now cosine of 2 theta, everyone, what I very simply do is I do it as cosine squared minus sine squared, both of which we have. So I'm seeing this as cosine of theta, square it, minus sine of theta, and square it. So remember, that's how it's going to play out, ratio squared. And I'm going to have to do this in 2 steps here, but I get 144 over 169 minus 25 over 169. And if I did that calculation there, it looks like just combining those numerators, I get 119 on that quickly over 169. So you're seeing some pretty complicated ratios come out here from what we started, but certainly quite legitimate. And then tangent, if you want to shortcut it at this point, this is y to r, this is x to r, so we would want y to x. I'm going to do it as sine over cosine, just I'm trying to be consistent here. But again, you'd probably see that this is somewhat unnecessary because those 169s go away, and I get this piece right here. And that's it. There are your primary three in a nutshell, all on doubling this angle right here. Now here's what's interesting. There's the first angle. I won't find its angle measure. I won't kind of go that far. But I guess what would happen if you double it? What quadrant would it end up being in? We should know. And so let's see. 2 theta, and this is how I'll kind of end it. 2 theta is in where? Well, let's see, everyone. Sine is negative. So that's either going to be somewhere down here. Cosine is actually positive. I think I've got it. And tangent is negative. So the only quadrant in which that happens, sine negative, cosine positive, tangent negative, it's in quadrant 4. So when you double this angle, here to here, and then double it, kind of comes down here somewhere. We could figure that out, as I said, but we did it on the last one. I won't belabor the point on this one. All right, so we combined with addition and subtraction. We combined by doubling, and the next one is combining by halving. And that's what we'll take care of on the next lesson. All right, everyone, of course, thanks for listening. I certainly appreciate it. And please let me know if you have any questions.